right, good morning again, and thanks, Dick, for having me and organizing this panel on the future of the digital factory. So I just want to, I think most of you participated in this morning session, except those who were, hung over from, the Disney show at Magic Kingdom last night and hanging out a little too late. But the purpose of our process, right, that I want to start off with is our platform is co-creation and micro-manufacturing. The whole purpose is to reduce the complexity in the value chain, as well as improve the speed to market capability. So going from concept to production ready in 6 months or less. Right now we're at around 2 years. And then, I think this is the laser pointer, yes. And so then the other thing is, and what Dick pointed out, there's a lot of things happening in factory and digitization in the factory and analytics. But we also think of our factory completely differently. We think of our factory as being truly an integrated experience that allows and enables industrial tourism. So most of you may have heard of the Ford Rouge plant down in Dearborn, Michigan, that you can take a really fantastic tour, right? You can go there, you can see and experience the history of it, you can see some vehicles, but there's one factory like that in all of the Ford network, right? And it's kind of the museum and their showpiece. Well, each one of our factories actually is open to the public. And so the purpose is to go into this factory, and I'll look at, I'll show this in a video in a second and talk about it a little more. And the other part that I talked about is, right, make it faster with less capital using more people. And to be able to always take the latest and greatest technology, whether that's Watson, whether that's some sensors from NXP, whether that is using direct digital tooling and materials to put in there, or whether that's even doing something that's not on the ground but in the air, and how to utilize our process for that. So how have we been going about developing the digital factory of the future? If you could bring up the video, and I can show this, because I think it's really good to show this conceptually in video rather than just talk about it. So hopefully let the internet work. Can you take the sound off? That'd be great. So this is a rendering of our factory in Knoxville, Tennessee. So it's right adjacent to Oak Ridge National Lab. But again, the point of our factory is not just to produce, it's really to be a design, development, production, and sales facility. So this is about a 50,000 square foot facility on about 10 acres. And this is literally, if you are down in Knoxville, I think Craig Sutton can attest to this. He saw most of it. Some of the, so the point is, right, on our facility, so you'll see 50,000 square feet, 10 acres to have the ability to test and develop vehicles right there. And then in each factory, we have a sales area. Craig, it didn't look like this when you were there in September, but it's looking more and more like this. Right? There's also a way to have and host community members that are part of our ongoing effort to design and develop vehicles. And you have a branded retail. So it's an immersive sales experience. And the perspective is that you come into our facility and you can use online or in our facility potential augmented reality to go and configure your vehicle, and we'll send it to print. Then we have what we call light labs. So this is our space where we bring in community members that are designers, hackers, makers, to help us co-create vehicles right there and then in our facility. So this is a relatively focused area that also has ability to have a classroom space, and it's also quiet. And then what we have, the Loud Lab, so this is more heavy equipment, heavy machinery, so CNC machines that are some more traditional manufacturing methods rather than the additive or subtractive. And then we have our final heavy lab, which is, in this case, set up for cell production of Ollie's, the self-driving vehicle. And these are the additive printers. So again, this is a different concept, right, of being able to work with a consumer or a buyer to design and collaborate on the vehicle and have that input from a consumer, then them coming in and configuring it, us actually enabling the click, print, drive, right? So the way that you can imagine it is you come and configure it, we send it to the printer, we assemble it in a matter of a couple of days, and you can participate in watching it being made, and then you can drive it out of the facility. Back here is actually some of the doors. The other thing that's interesting, we have an overhead crane. So we are actually also a value-added reseller for some of the tooling, and that can be moved to the exit where you can have a truck come right in and take it out of our facility. So that gives you a little bit of a perspective of how we are rethinking the concept of factory and production and making it industrial tourism, as well as making it a sales point and engaging the consumer directly at our facility. All right. And that's who. If you need creative animation, you know who you can go to. All right. Yeah. So fantastic. So that's a little bit about the concept. Now I want to talk a little bit about, in more detail, about the tools and the materials that we're really developing at the Factory of the Future that enables this direct digital process. So a lot of times when you think about additive manufacturing, there's some really soft biological systems, right, that additive is being used for. And then you got some high performance metals that a lot of organizations like GE, right, is thinking about how to use additive for various precise technical applications. We have actually decided to focus on polymers because between here, this is kind of 1% applications, this is another 1% applications. We think there's like a 98% set of applications that in automotive and in vehicles we can apply. And so on occasions our team gets bored, so they create furniture, but primarily we use it for vehicles. And we've used it from everything like the Strati, which has about 90% additive content, to a Swim, which is roughly 50%, to the Ollie, which is ballpark 30%, and primarily the interior components and body panels are actually made off of 3D printed molds. So it's thermoformed plastic that's actually not 3D printed, but the molds that created the thermoformed plastic was 3D printed. So we're even using it in a tooling perspective to save us time and cost on tooling requirements. The other thing that I want to advocate is, right, there's certain things that still don't make sense to be additively manufactured, right? If there's certain things that just, you want to make 10,000 of them and you can get a die or a mold made, go make it and stamp it and use traditional manufacturing methods. What our perspective is, we're in this lower cost per unit, fewer units, right? I said each facility has about 1,000 to 3,000 units that we plan to make annually, and of each product, we probably never will make more than 10,000. If there's demand for more than 10,000, we'll partner with somebody who is in the business of large-scale manufacturing and wants to have that capital cost and can justify it based on their business model. So we believe in economies of scope versus economies of scale in the Factory of the Future. The ability to use low capital intensive tooling and then help, and actually, the cost per unit, if we can keep it down, we can actually, the price per unit, we can charge a premium because it's a niche product that other people or other OEMs may not want to make. All right, I have, so this is what is large scale additive manufacturing, right? In our perspective, it's the industrial scale, and you can see kind of the bed. This is about $1 million machine, and this is how you do it layer by layer. And I have a short video to explain a little bit about the digital process. But essentially, we're taking raw material, carbon fiber reinforced plastic. we have pellets, so it's pelletized carbon fiber, and we take that and dry it in a dryer, and then we pull it into the extruder, and this extruder head lays material in 3 dimensions, X, Y, and Z. The strongest layer is in the direction of print, which is in the direction of the carbon fiber. The second strongest is the Y, and the weakest is the Z from an adhesion perspective. But on the X, we're getting some really cool material fatigue properties, where with certain compounds that we're creating, we're getting fatigue properties of like a 1045 steel almost. And I'll show that in a little bit. Can you actually click on this? And this time you can have the sound on.
Auto show this year.
Yes.
My first question was, will this meet the crash standards?
Yeah, we're seeing, and we've just started going through the process, but the answer is yes. And if you ask why, it's because
Siemens and Local Motors advancing 3D printing for real production.
In steel, it's really just like one instrument from a suit.
3D printing is changing the world of manufacturing.
Inside the unibody car.
So
It
this is
empowers
we're
designers
working
to
closely with
reimagine
Siemens,
the way
and what the
products
video
are
shows is similar to the time lapse I showed
change
earlier.
afternoon
how
print.
they are
But
made.
you're also talking about how it extends beyond the additive part.
3D
And it's
printing
hard
allows
to hear
companies
because I
to
think
innovate
there's 2
fast.
Not having to do all this tooling, doing things on a micro scale. I gotta
world-changing
believe
ideas.
This is down in Knoxville
They're
again.
regular
But
manufacturers.
what you're talking about here is what
Local
Dick
Motors.
mentioned earlier is also the ability to
A
create
technology
digital
company that
right?
co-creates
So
and
we want to
3D
co-create
prints
3D
vehicles
print
in
vehicles and
microfactories.
and
Local
we
Motors
create
is
digital twins of the vehicles, but then we also create digital twins
3D
of
printing
the facility.
wide range.
So we've done this, for example,
you do a couple
in Knoxville.
is helping makers
Working with
design digital
organizations like
twins of products.
Depending on the contact,
Depending on the configuration that you use the customer.
So you can actually mute it.
I think it's really exciting that
And
you
we'll go, I'll just talk through it. So that was the digital twin of the product, and this is the digital twin of the process, right? So showing the additive part within the tooling. And so just, again, using some of that directly at our facility, and from a simulation perspective, what gets really interesting is we can simulate a print, and we understand where potential hot and cold points are, and we can alert then our machinists and our operators to go and monitor those specific things where we may have to slow down the machine in order to not get any delamination issues. So this is, we're also deploying some of this software to our global community to help them with the co-creation process. So that was showing that we can actually X out of that. It was a nice voiceover, but because the 2 videos were both playing, we'll just go back to the presentation.
Partner with anybody else in Siemens?
Yeah,
Automation?
we have partnered with other organizations. None of them that I can name right off the top of my head right now, because our team in Knoxville leads a lot of that effort. All right. So then, why large-scale additive? And so, as I mentioned earlier, or as Dick mentioned earlier, you can really make some functional complex part geometries that you just can't make via traditional manufacturing. And our partners at Oak Ridge National Lab and IACME have been really great in working with us on that. The second part, as I said, is tool production and this cost savings and time savings for tool production that we've seen, especially for the Alley, have been tremendous. And then this is a study from, I think, Oregon National Lab that shows just the efficient manufacturing process in terms of process rate versus electricity requirements. And the BAM is really at a good position. So we think there's a significant future in large-scale additive manufacturing. And so, as I mentioned earlier, the original Strati was around 1,000 pounds. Right now, we're using some multi-materials while not reducing some of the strength. We've almost reduced the weight by 48%. So there's also some real innovation going on while continuing to reduce weight, but improving the time, the speed of print, as well as the quality of and strength of the print. And so, again, our perspective is this isn't just research for fun and games. We're actually applying this. So this is the fender on the Strati, for example. In the case of the Strati, the entire body is also 3D printed. We similarly, the wheel well on the Ollie is 3D printed. The entire facade here is 3D printed, and the floorboard. And then again, this is the tooling that we 3D printed that created a lot of the interior thermal formed componentry. So that gives you a little bit of a sense of the digital factory of the future from both of rethinking manufacturing and the purpose of a manufacturing site to also have design, development, and sales, and also some of the big area additive tooling and materials that we're applying to bring direct digital manufacturing to our production sites. So thank you, and I'll look forward to taking your questions. Gentlemen, thank you very much.